How fast can you look at a problem, find a solution, and then actually start implementing it with then a product coming out at the end of it is essentially what we were trying to target.
The Submarine case study is definitely an example of how the AMRF can bring a whole bunch of expertise together, help manufacturers de-risk, innovate, and scale.
To me, it's just a really interesting challenge, which is we have these manufacturing techniques that have existed for a very long time that we're relying on that probably haven't gotten the amount of attention they've deserved over the last couple decades.
And typically these kind of marine valves, the design of them has stayed pretty stagnant as it's been linked to kind of casting methodologies for manufacturing them. And so when we were looking at it from using the tools within the AMRF, we found that there was potential to really decrease your time to market, but that required adapting the design so then you could actually manufacture it as quick as possible.
So we wanted to achieve at least equal performance to the traditional valve, but make it easy to manufacture.
It turns out that valve housings are in massive demand, not just for defense applications, but there's a direct translation from that application to all these other fields. So oil and gas, aviation, space. Our ability to control flow is not, isolated to one industry specifically. So talking to our, design and applications team, what would it take for us to make it? What's best suited for this type of technology?
The team engaged in the computational fluid dynamic analysis to take a look at what was actually happening inside of that valve and make sure that whatever we were producing at the AMRF was not just faster, cheaper, and easier to make, but also something that performed to a much higher standard.
The methodology we took was to kind of do a flow analysis on it and try to figure out what actually the most optimized flow regime through the path was.
We took this marine valve, which is made using casting, and then optimized the design of it so that it's easy to manufacture using CNC machine.
I think people are really surprised to know that we actually did machine the duplex stainless steel. It is such a difficult material to cut out on the CNC machine.
Duplex stainless is no fun. The team really stepped up to a challenge that I didn't think they saw coming when they signed up.
Part of what we're looking at is those difficult problems and to kind of give a bit of confidence to say, yeah, it can be done. You can take these on and actually do them.
We're not focused on basic research. We're not here to reinvent the wheel. It's more how do we parameterize it and do a best fit for the most possible cases.
It shows through an actual example the kind of difference that the AMRF can make for manufacturers and to the sector as well. So these are the types of things that we can help with, and we're really keen to talk to manufacturers about that.